Okay. The next thing Alan did was combine those two things, the continuous random variables with probability. So now we are going to look at a function, and he defined the function of f of x equals 1.5x squared if x is between -1 and 1, and for every other value of x at 0. So I've drawn the function here. This is the graph of y equals 1.5x squared between the values of -1 and 1, and for everything else it's 0. So the first question is maybe why did he limit it to -1 and 1? So let's integrate this and find out. So if we integrate this, we use that rule again, the same rule that we've been using. We add 1 to the power, so we get 1.5x cubed, all divided by 3, and it's between our limits of 1 to -1. Now, the nice thing about this is 1.5 divided by 3. 1.5 divided by 3 is just a half. So what we've really got here is 0.5x cubed between our limits of 1 and -1. What's the next step that we have to do? We have to substitute our limits in. So when we put 1 in here, we get 0.5 times 1 cubed minus 0.5 when we get -1 cubed. Now, you've got to remember a few rules here, but 1 cubed is just 1. So 0.5 times 1 is just 0.5 minus. Now, -1 cubed is -1, so 0.5 times -1 is -0.5. And that gives us 1. 0.5 minus 0.5 just gives us 1. And that's exactly what we would expect, because if this is a probability function, then the area under this curve should be 1. And that's exactly why Alan limited it to -1 and 1. So the area under this curve, that's what the integral gives us. The integral from -1 to 1 gives us the area under the curve between -1 and 1. And the sum of all the probabilities has to be 1. So is this a probability distribution? Yes, it is. So how can we use that? The next thing Alan did was he took it from -1 to some value of y. So let's integrate again, and it's the same sort of rule, and we'll come up with it pretty much exactly the same thing. 1.5 times x cubed over 3. Add 1 to the power and put it over that between our limits of y and 1, which equals the 1.5 over 3 is still 0.5. When we put in y, we get y cubed, minus when we put in 1, which is 0.5 times -1 cubed. And the same thing sort of happens here, that -1 cubed gives us -1, and a minus times a minus. So what we've really got is 0.5 y cubed minus 0.5, or Alan took that out as a common factor of 0.5. What's left inside the brackets? Y cubed plus 1. Sorry, that's a minus times a minus should give me +1 up here. Okay. So now we want the probability that x is less than 0.5. So this gives us the area from -1 to y, this function here, from -1 to y. But instead of y, this is going to become 0.5. So how do we find this area here? We just substitute 0.5 in for y. So instead of this, to find the probability that x is less than 0.5, that is just going to be 0.5 times, instead of y, we're going to put 0.5 in, 0.5 cubed plus 1. And we've got a calculator. We can do that on the calculator, and what we get is 0.5625. So about 56.25% of the time, our value is going to be less than 0.5. Sort of makes sense. This is 50%, and we'll use this sort of stuff when we look at z-scores. So this is 50%. This is the extra 6.25% just here. Okay, but we will look at that. You understand that this is 50% because it's half the graph, or that symmetry, hopefully. The next example Alan looked at was, but what if x is greater than 0.3? So in our diagram over here, we're looking at this area here, but this function always gives us this area. This time we want this area, so it's a bit, I don't know, trickier, I guess. But the thing that we've got to remember is the whole area from -1 to 1 is the sum of all the probabilities, and the sum of all the probabilities has to equal 1. So what we've really got, instead of looking at this, what we're going to look at is the probability that x is less than or equal to 0.3. Because we've got a formula for that, we can just put it into this formula. So p of x is going to equal 0.5, 0.3 cubed plus 1. And again, we can do all of that on our calculator. And what we get for this is 0.5135. But that's not the value we want, because that's this value. We don't want that value. We want the other side of it. So what we want is really p of x is greater than 0.3. This function will always give us less than. So p of x is greater than 0.3 or 0.3 is always just going to be 1 minus the 0.5135, which gives us an answer of 0.4865, or 48.65%. And this sort of makes sense if you look back at the last answer for 0.5. For 0.5, we said that this area here was 6%, this was 50%, this was 6%. That's how we got the 56.25. So we would expect that 0.3 is less than that. What did we find 0.3 was? 0.3 was the 1.35%, 50% being here and the 1.35% being here. So that area there is 1 minus that, which is 48.65%. Okay. Hopefully that clears things up a little bit at least. Thank you.